These are all common molecular genetic tools that were already at CBAY. They're in the Philippines, they're in Indonesia, they're in every country I go to. These tools are already there. It's nothing fancy. And it's increasingly cheaper and cheaper to use. So really quickly, our results from the Philippines was the first time I've ever tried this. We were able to obtain fish water, filter the fish water and get DNA, and we were able to successfully amplify DNA barcode for these organisms. And we targeted only fish. And for those of you familiar with molecular genetics, these are good. These are the bands that let us know that we were successful in this approach. Okay? What we tentatively showed in the Philippines is that this method could work. We could get DNA from leftover fish water scooped up out of vessels, and we can identify the presence, not the absence, but only we can confirm the presence of an organism based on the DNA. And sometimes it shows us things we didn't even see. This is a container of squid, calamar, right? That was at a fishing port in the Philippines. And in this container, all you see is squid. I moved it around. All I saw were squid, and I scooped up some of that water. And we did the barcoding, and we found this. Nowhere in here did I see a fish, but that fish DNA was left over in there. Things that we don't even see with our eyes are left for us to find using the genetics. But again, how do we use this in fishing, illegal fishing? We tried something here where we want to meet these goals to fight illegal fishing, to improve monitoring, control, and surveillance of fisheries. How do we do that? It's too difficult to go to every fishing port in the world and scoop up water from every fishing vessel. A better idea is to find the vessels we think that might be doing something suspicious, something illegal, and check them. So here in Ecuador, for the first time, we decided to push the science further. We coupled eDNA with another new type of technology. It's called Automated Ship Identification System. And to be fair, this technology has been around for a few decades, but there's new tools that we can use. So AIS is a type of onboard transponder that sends a signal up into the air to tell a ship where is it, what is its name. Okay? So this was developed actually so vessels won't collide in the ocean. Okay? But that data is already available. The reason why we can use it now is because of new satellite technology. In the past, you would have a fishing vessel and it would send its data, but because of the fact that the Earth is curved, that data won't make it back to the receiving station. Recently, AIS has made it possible where we don't need to be close to shore. We can pick up data from multiple vessels all at once. Additionally, we don't just find out where the vessel is, but also we can use that data to say, what is it doing? Here we have a density plot, and this is the speed of different vessels. And this is the vessels are moving very slowly, this is the vessels are moving very quickly. What we can do is look at that data and get an idea of basically, are they fishing or are they cruising? Are they moving around? And if they're fishing, where are they fishing? So now we have this tool that allows us to see where a vessel is, when was it fishing, because we can look at the speed and the date, and we can actually see when vessels all come together in one location. And all we need to be able to do now is to make it available to use. Okay? And recently, with the support of Google and SkyTruth and the Leonardo DiCaprio Fund, Global Fishing Watch launched this free public map of where you can track fishing vessels all over the world. So here's the continents, we have the blue of the ocean, and the lights, those are all fishing vessels, all over the world, in nearly real time. We can see the data from 3 days ago of where all of these fishing vessels were. We can zoom in on Ecuador, so here's Manta, and we can see all of these lights. These represent fishing vessels that are coming in and out of Manta. We can click on one of those lights, and it lights up, and it turns pink, and this tells us the vessel had come into Manta, left, came back, and left again. And further, we can get an idea of what type of vessel was that. we can see it was a fishing vessel from Panama. This is the name. This is what it looks like. And here's all the information about what it does. So basically we can go out and we can see all we want to know about these fishing vessels, and this is free. So you can go to this website and check it out yourself. We can also look for interesting patterns. I apologize, it's hard to see. Here's the Galapagos. Here's the coast of Ecuador and Peru. Here we have this interesting scenario where there's a blue vessel that is coming through the region and leaving. And it's very hard to see, but here's the economic exclusive zone for the Galapagos. Here is of Ecuador, and in between we have an area called the high seas, international waters. That vessel moves into the high seas, and a vessel from Manta comes out and then goes back to port. What happened? Well, these vessels were moving together at 2 knots for 8 hours. What can happen when 2 vessels come together for that long time? Maybe they're transferring fish. And that is perfectly legal, but it might raise a red flag if there was something else suspicious about this vehicle. So what we can do is we can make alerts that let us know this is happening, and then we run to the fish port, and we jump and we grab some water samples. And we can use the DNA method to find out what it is. So we tried this. We went to Manta with the help of SkyTruth and Global Fishing Watch. We got a list of vessels that were coming into port. These are not the vessels we surveyed. I'm just putting some examples for privacy reasons. I don't want to release the data yet that we found. We found vessels that were coming into port. This is one of the fishermen who basically threw a bucket into the fish hole, scooped up some of the water. We wrote down what the fishermen said they were catching, and then we applied our eDNA method. Our results? We were successful in getting sequence data from those samples. Okay, this is the preliminary data. We are waiting for our export permits so that we can actually do the full analysis, but this is what we were able to do here at SCOL. But here's what we found. We sampled 3 commercial fishing vessels. They were all purse seiners, and these were the fish that they said they were targeting. Using the eDNA method, scooping up the water, this is what the genetics told us they had. So we see some matches. Here's albacora, here's albacora. Okay? So it's working in that sense. And you might say, well, why don't you have all of these fish here? Again, we're only able to do the preliminary data. We're, again, waiting to do the full sequencing run in a few months. But it's showing evidence that we can identify the fish that they say they found. Interestingly, we don't see marlin in what they reported catching. Oh, is it? Okay. Okay. Sorry, common name. Thank you. What about at Santa Rosa? Same thing. We looked at artisanal vessels that were using line fishing, and this is what they said they caught, and that's what the genetics told us that they were able to find. And so we're showing this match, agreement between these technologies. So what we can do is we can go out and we can find vessels that are doing something that makes us interesting, seeing which potentially are the bad actors. We can sample 1 tube of water, and we can identify everything that they're catching. Some people ask, what's the cost to do this? Right now it costs us about $60 US to run a sample. And the problem with that is, again, we're still developing the technology. Still, that's relatively cheap if you think about how much does it cost to train a person, send them to the port, and stay there all day to count the fish, when all you really need is a scoop of water. Okay, so there's advantages and disadvantages. But this isn't it. Already we're thinking about what do we do next. Using public databases for genetics, my hope is within the next year, we can start geolocating the fish. And what I mean by this is that if we have a fish that we get genetic information from, here's a tongal, and the genetics says that it's got this gray fingerprint, this gray signature to it. That tells us something about where this fish is from, okay? And what we can then do is use the public database and compare. Is this fish from Thailand or the Philippines? Is it from Fiji? No. It has the gray signature, therefore it's likely from Ecuador and Peru. I'm not there yet. We haven't figured out quite yet to do this, but I think we will get to this point using the concepts from population genetics, using unique haplotypes to link a location to a fish. Additionally, The last piece of this is the idea of how many fish are in here. Can we use this method to figure out a proportion of different species? So for example, this is from manta, and what we see in here are